Okay, so what I want to show you today is how do we add fractions with the same denominator, get an answer, and then simplify the answer. So here's how this works. For today, for what we're doing right now, we're only looking at fractions that have the same denominator, the same bottom, okay? Fractions with a different denominator, that's another lesson for another time. So today it's just fractions with the same bottom, same denominator. So what we do is we keep the bottom the same. It might seem kind of odd. We don't add the bottom, but we do add the top. So if I've got 2 out of 10 and I'm adding it to 3 out of 10, my answer is going to be 5 out of 10, okay? So the bottom I don't add, bottom I keep the same, but the top I do add. So 2 plus 3 is going to equal 5. So what I'm left with is a fraction that is totally reasonable, but it can be made smaller. Here's how we do this. There's a couple tricks you can do. You can always try and divide by 2, try and divide by 3. An easy one too is to see can the number on the top fit into itself and the bottom. And in this case, I know that 5 goes into 5 because here's 5 fingers. Can 5 fit in? Yes, there we are. Once, fits in, done. 5 can fit into 10 quite nicely. So instead of starting with 2, I'm going to actually just see if I can start with the same number. And I know I can because I'm really good at my 5 times table. So watch this. I'm going to go, what is 5 divided by 5? And what is 10 divided by 5? 5 divided by 5 is 1. 10 divided by 5 is 2. So this first part, this is kind of step number 1. This is kind of like step number 2. We've got a fraction. We add the top numbers together. We keep the denominator the same, but then we want to simplify. This is kind of the second part. It's like, I can't even think of an analogy. It's like making a cake and then you're like, okay, now let's eat it. You don't just want to make a cake and be like, I made it, and then just sit around and look at your cake. You're like, let's do something with it. So what we're doing here is, again, we divide the top and the bottom by the same number. I've seen students where they're like, oh, I can divide 5 by 5 and I can divide 10 by 2. And that's a good beginning point. But we have to divide them by the same number. If we don't divide it by the same number, it doesn't work. So let me show you one more example about how we do this. So let's go 15 because I can do, no, I'm not going to go 15 because I just showed you my 5 times table. 5 times table, let's do 20. So 20. Let's go, what is 10 plus 4? That's kind of nice and easy. So I've got 10 out of 20, and I've got 4 out of 20. I specifically chose even numbers because I know in my mind I want to give you an example I can divide by 2. But let's just see what this looks like. The bottoms, the denominators, I keep the same. I don't add them. But the top numbers, the numerators, I do. So 10 plus 4 is 14. Now this is where it gets kind of tricky because you almost have to think of what numbers go into 14. I know that 1 goes into 14. I know that 2 goes into 14. I know that 7 goes into 14. And I know that 14 goes into 14. I'm really tempted. I want to divide by 7 because I'm like, ooh, that's kind of a big number. 14 doesn't work, and I can tell you why. Because 14 doesn't evenly go into 20 with another 14 left over. It's either 14 and extra left over, or it's not going to work, right? So I'm going to cross off 14. There's no point in dividing it by 1, because if I divide it by 1, then I'm not simplifying it. I'm just keeping it the same, right? Because then I'd go 14 divided by 1 is 14. I haven't really done much. So I'm kind of left with 2 and 7. I know that 7 doesn't go into 20 because 7 times 2 is 14. 7 times 3 is 21. So it's not quite an even fit. So I'm kind of left with one choice, number 2. So I'm going to go 14. Let me just erase all this. That was kind of like my brainstorming session there. 14 divided by 2, 20 divided by 2. So 14 divided by 2 is 7. 20 divided by 2 is 10. And you might look at this and think, but there's numbers beneath 7 and there's numbers beneath 10. Maybe we can make it even smaller, even simpler. You're kind of correct. We want to make it smaller. There are numbers beneath it, but not the same number. There's no other number that goes into 7 evenly that also goes into 10 evenly. So this number is as small as we can get it. I'm going to show you one more example and we're going to call it a day. So let's do 12. So I'm going to go. So very nice one here, out of 12. So 12, 12, 12. I'm going to keep the bottom the same. Okay. My denominator stays the same. When I add my numerators, that's when I can have a different number. So 4 plus 2 equals 6 out of 12. So again, this is where it kind of helps if you kind of know, I haven't talked to you yet about factors. I haven't made a video on that. But if you look at what are all the numbers that fit evenly, like through multiplication into 6. I've got 1, I've got 2, I've got 3, and I've got 6. Like 4, you might be like, but 4 fits into it. It does. But watch this. I've got 1, 2, 3, 4, 5, 6. I can fit 4 in, but I've got 2 random bits left over, which means it doesn't fit in evenly. It doesn't fit in nicely, smoothly, completely. We need numbers that fit in nicely, smoothly, and completely. So when I look at all my numbers, 1 isn't really going to do much. And this is where actually, I'm going to show you we've got 2 roots here. We're going to divide it by 2, and then we'll divide it by 6 and see what happens, okay? So let me erase. I'm going to simplify. Let's do this. So I've got 6 over 12, and I'm going to divide the top by 2. So what happens if I go 6 divided by 2, and I've got 12 divided by 2? 6 divided by 2 is going to be 3. 12 divided by 2 is going to be 6. So 3 out of 6, this is a nice small number, right? Like I've taken a bigger number, and I've made a smaller number. This is very exciting. The thing, though, is I can actually make this even smaller, which is kind of my goal. So I have to look at the numbers that can fit into 3. And the numbers that can fit into 3 are 1 and 3. So there's no point in me dividing it by 1 because then I'm just going to get the same number. So I'm going to divide 3 by 3, and I'm going to divide 6 by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So when I originally started with 2, I had to simplify a few times in order to get to the smallest number. Let's see what happens if I simplify using 6. So let me just clear this off. So I've got 6 over 12. And my go-to always is 2, because you can always go 2, 2, 2, and keep coming down. Sometimes I forget to be like, oh, let's try a bigger number. So let's try 6. So what happens is if I go 6 divided by 6 and 12 divided by 6, what happens? 6 divided by 6 is 1, right? 6 goes into 6 one time. 12 divided by 6 is 2. 6 goes into 12 twice. So I got the same answer in fewer steps. Does that mean it's more correct or whatever? No. Like as long as I get to the final answer, it really kind of doesn't matter how I get there. This is probably more fluid. You might be the kind of person where if you're really good with your multiplication tables, you might be like, yeah, I'm going to do this. If you're like me and you're like, good old 2, let's always try 2. That's fine. You might just have to keep simplifying. But there's our goal. That's how we add and then simplify. All right. Good luck.